Multiplying large numbers sounds simple until the numbers become so big. So instead of doing it the slow way, what if we can make multiplication faster by working smarter? That's where Karatsuba algorithms comes in.
Karatsuba algorithm is a fast multiplication algorithm introduced by Anatoly Karatsuba in 1960. It was designed to speed up the multiplication of very large integers by reducing the number of multiplication operations needed. Instead of multiplying numbers digit by digit, the algorithm applies a divide and conquer strategy, making it more efficient for large inputs.
This algorithm is a divide and conquer algorithm. It recursively splits the number, performs the required calculations, then joins the results to get the results of the multiplication. It's the same paradigm that merge sort uses. Remember that it split the array into two parts, sorts them, then join them to get the sorted array. I don't want to directly jump into how the algorithm works because you wouldn't understand the reason behind the different instructions, so I prefer starting with the logic behind the algorithm. For example, 146,123, which has 6 digits, and we split it into two parts, A and B. Here is a 146 and B is 123. We know that X is 146,000 plus 123, which is equal to 146 times 10 power 3 plus 123. 3 because it's the half of 6 in the number of digits. In a general way, x is equal to a times 10 power and divided by 2 plus b. In our multiplication, we have two numbers x and y. We know that x is equal to a times 10 power and divided by 2 plus b. And we can do the same thing with y. We can name its parts c and d. We get y equal to c times 10 power and divided by 2 plus d. Now, if we want to get the result of x multiplied by y, we can calculate a times 10 power n by 2 plus b multiplied by c times 10 power n divided by 2 plus d. Let's distribute. We have a times 10 power n by 2 times c times 10 power n by 2 plus 80 times 10 power n by 2 plus bc times 10 power n by 2 plus bd. The first term is ac times 10 power 2 times n by 2, and you can combine the second and the third term. We get 80 plus bc times 10 power n by 2. This expression means that if we want to calculate the product of two numbers x and y, we can split them into two parts a and b respectively, and we evaluate this expression. Okay, but to do so, we need a value of ac, bd, and 80 plus bc. To get them, guess what? Recursively call the function again. Remember that it is a divide and conquer algorithm. We divide the multiplication xy into smaller multiplication that we're going to join later. Here, you may think that we need 4 multiplications, one for AC, one for BD, one for AD, and one for BC. But no, we only need 3, one for AC, one for BD, and to get the value of AD plus BC, we calculate the value of A plus B times C plus D, and we subtract AC and BD. The reason behind it is that a plus b times c plus d is equal to ac plus AD plus bc plus bd, and if we subtract ac and bd, we get the value of AD plus bc. Now that we got the values we need, we can finally calculate the expression that is in reality the value of x multiplied by y, the one we're searching for. And that's how the Karatsuba algorithm works. In summary, we split x and y into a, b, and c, d respectively. We calculate AC, we calculate BD, we calculate AD plus BC, and we return AC times 10 power 2 times n by 2 plus AD plus BC times 10 power n by 2 plus BD.
Karatsuba reduces the number of multiplication operation and performs better for large integers. It is commonly used in applications like cryptography and large computation. However, the disadvantage of Karatsuba algorithm, it relies on recursion and it creates intermediate values, which increases memory usage. Because of this overhead, Karatsuba may be slower. than classical multiplication for small inputs.
So hi, today I'll be explaining the Java program that multiply two binary number using the Karatsuba algorithm. So um, I call the multiply method to multiply the binary string, this 1100 and 1010. All of these line all of these line test different binary input. The program print the multiplication result for each pair. This function make both binary string the same length by adding zero. So um and length 1 and length 2. We store the length of both string. And then this if the first string is shorter, I add leading zero until both length match. Then this else if um if the if the second string is shorter, I added leading zero on the one, then return len. Now the both string are equal. So this function add two binary string with carry just like a normal addition. Um, we create an we create an empty string builder for our sum. Then then we call the previous function to ensure both bit string have equal length. So we should start with zero, then 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 for I for this if we loop from the last digit to the first, then this is to convert character bit 0 or 1 into integers. Then we compute the sum using XOR logic. Then we insert the result at the beginning of the string. This line calculate the query for the next bit. So if there is still a query left at the end, I add a one at the front. Then return uh return the final binary sum. This multiplies to single bit. It basic 01 x 1 1 times 1. This this is the main function that multiply two binary string. Then we format this line is we format the binary string so they have the same length by adding zero on the left. Then if both string are empty, return zero. Return zero. Then if both string have a bit one, multiply normally. Then um, this line is how many bit will go to the first half and second half. Then this line split x into left and right halves. Then we split y into left and right half. So this P1 only multiply the left half. Then this P2 multiply the right half. Then this then this P3 multiply the sum of both halves from x and the sum of both halves from y. This is the special trick in Karatsuba. Then this line, we combine P1, P2, and P3 using bit shifting. It create it recreate the full multiplication result just like long multiplication. So the result 120, 60, 30, 10, 0, 4, 9, 9.
Karatsuba showed that even the basic operation like multiplication can be made faster with the right algorithm. It becomes a powerful tool in the large number computation by reducing costly operation and apply divide and conquer.